This is Engage New York, Module 3, Lesson 4, Concept Development. All right, so let's look at this first problem. When you see this problem, can you estimate the answer? So think about that for a minute. Can you estimate? Will it be more or less than 1, your answer? Will it be more than 1? So think about it. If you had 1/3 and 1/4, and you put them together, would you end up with more than 1? Well, the answer is less than 1 because 1/3 and 1/4 are both less than 1/2, right? So if they were more than 1/2 and more than 1/2, then when you put them together, yes, you would end up with more than 1. But so if two fractions that are each less than a half are added together, they will add up to a fraction less than 1 whole. So let's take a look at our problem. Let's look at this right here. Now, we want to add these together, but if you can see, they are not on the same number line. They are not like units. So we have to do something to create like units. So I've showed you before the scoreboarding. So if you still need help with your math facts, you could use the scoreboard method. So if you notice, I took the denominator from the first fraction and I took the denominator from the second fraction. Now, if you do times 1, times 2, times 3, times 4, times 5. Now, if you do know your multiplication facts really well, then you're going to start catching on to what the common denominator is going to be so much faster. But if you don't, and you're still trying to get a hang of this, you can use the scoreboard method. So denominator, denominator. Now I'm going to do 1 times 3 is 3. 1 times 4 is 4. 2 times 3 is 6. 2 times 4 is 8. Now what I'm trying to look for here is where I come up where they both have the same number they each have the same number in each column. So we're trying to find what's the common number that they share. 3 times 3 is 9. 3 times 4 is 12. 3 times 4 is 12. Oh, I can stop right there, right? They both share the number 12. So because we're always looking for the lowest common denominator, we know that 12 is going to be their common denominator. Now, if I came over here, I could do the same thing over here by multiplying by 4. 1, 2, 3, right? If I have 3 lines, I make four sections, right? So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So now I know if I multiply by 4, I'm going to end up with 4 12ths. And if I look here, 1, 2, 3, 4. So 1/3 converted to 4 12ths, right? And remember, I didn't add more space. I just added more pieces. And the 1/3 is equivalent to 4 12ths. So I know now 4 times 3 is 12. So I know if I come over here, I'm going to section this off. I'm going to multiply this by 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, look, I have 12 pieces again. Did I add more pieces? Did I take up more space? No, I kept the same amount of space, but created more sections, created more pieces. So now I have 1, 2, 3 out of 12. And what did we do? We multiplied by 3, and we end up with 3 12ths. So now 4 12ths plus 3 12ths is equal to 7 12ths. All right, we can do that same thing with our next problem. So ask yourself again, oh, look, here's 1/2, and I'm adding 3/4. So if you think about that for a minute, Do you think our answer is going to end up being more than 1? And if so, why do you think that? Well, we know that 3/4 is more than 1/2. And if it's added to 1/2, well, we're going to have an answer that is more than 1 whole, right? So what stops us from just simply adding? Why can't we just add these together? You're right. The units do not match. So now we need to have the units. We have to try to create an equivalent fraction so that the bottom units match, so the denominators match. So, well, we can also always use the scoreboard method. Take our first denominator, take our second denominator, multiply 1, 2, 3, 4. You can keep going. But I'm going to just go to here and see what I end up with. 2 times 2 is 1. 4 times 1 is 4. 2 times 2 is 4. Oh, wait. Well, that works out nicely. They both share 4, right? So do I need to do anything to this one? I'm going to actually keep 3/4 just the way it is, right? So here is 1/2. Here is 3/4. So here's my 1/2 plus my 3/4. Now, I'm going to multiply 2 times 2 is 4, right? So I'm going to multiply this by 2. Whatever I do to the bottom, I do to the top. So now I'm just going to divide this. I'm going to multiply this by 2 essentially by doubling it, right? So now I have 2/4 plus 3/4 is equal to 5/4, right? Well, now we're ending up with an improper fraction. So it's we don't like to leave a fraction improper because we can actually write this as a mixed number. So if I know that 4/4 is hiding inside of 5/4, because I know that 1/4, I know that 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. I have 1, 2, 3, 4, 5, right? 5 1/4, and that's what this is telling me, 5 1/4. So if I capture 1, 2, 3, 4, if I have 4/4, I know that equals 1 whole, right? And what is left over? 1/4. So what I like to do is I like to just pull out the whole fraction right away and then see what's left. And I end up with 1 1/4. All right. Hopefully you're taking that all in. All right. So now what we're going to do is we're going to go on to problem 2. Okay, we're going to go on to problem 2 here. So now we have 4/5 and 1/2. 4/5 is more than half, right? Plus another half. So would you estimate, would you guesstimate, would you use what you know about how much space that takes up? Look, 1, 2, 3, 4. So I have 1, 2, 3, 4, 5. I have 5 pieces and 4 of them are taken up. And then I have half over here. So do you think my answer is going to be smaller than 1 or greater than 1? Well, you're right. It's going to be greater than 1 because this is clearly more than half, and then you're adding it to a half, right? So what I want you to try to do is I want you to try to scoreboard off to the side here to find your common denominator. I want you to show me how you broke up or you added pieces to your fractional wholes. And then I want you to show me what you did. How did you add up your fraction? And what did you do with your fraction once you added it up? All right, come back and check in as soon as you tried number 2. Okay, so did you scoreboard and were you able to find your common denominator? So when you do that, you come over here and go, well, I'm going to multiply this by 2. So I'm actually going to double this, and I doubled the amount of pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8, right? I have 8 tenths. Then over here, 2 times 5 was 10. So now I need to add 5 equal pieces over here, and now I have 10. So both fractional units, squares, have the same amount of units. So they both have 10. I multiplied by 5, right? Added 5. So I ended up with 5 tenths. So I add 8 and 5 is 13. And then on addition, you just carry that denominator over because we're working with the same units, right? So if you added them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, you have 13 of the tenths. So I'm going to pull the 10 over 10 out, and I'm left with 3 tenths. So I have 1 and 3 tenths. So you could also do it this way. Well, it takes 10 1/10ths to make one whole, right? And then you have 3 tenths left over. So 1 and 3 tenths. All right, let's try another one. So over here, we have 2/3 and we have 3/5. So you have 2/3 and then you have 3/5. One, two, three, four, 5. Yep. And I end up, I'm going to shade in 3/5. So is your answer going to be greater than 1 or less than 1? Well, just by looking at this, you know when you add these up, you're going to end up with an answer greater than 1. So what I want you to do over here is I want you to try to scoreboard until you get the hang of this, until you can start seeing those denominators, using what you know about multiplication, your multiplication facts to figure it out and to move faster, because you'll just get so much faster at it if you start seeing the common denominators that tend to go together. So 5 and 2, generally, you're always going to go with 10 because that's the smallest product that they both share. Okay, so I want you to go ahead. I want you to try number 3 and come back to check your work. Check back to see how are you solving this? Are you following the same steps that I am? Are you following? Did you start by scoreboarding? Did you come over and divide up your fractional wholes? Were you able to multiply to get your equivalent fraction? Because remember, these 8 tenths is the same as 4/5, and 5 tenths is the same as 1/2. So you're creating equivalent fractions so that you can actually add these units, because you cannot add these units unless they share the same denominator. All right, let's go ahead. I'm going to set you free. I'm going to see how well you do and come back and check your work. All right, so now that you've solved it by yourself, now you're coming back to check your work, right? So we scoreboarded. We know that it's 15 and 15, that 3 times 5 is 15, and 5 times 3 is 15. So when I come over here to my 3, my fraction with the 3, I have to multiply it by 5, right? So I add 4 lines to break it up into 5 equal parts, which increases our number to 15, our pieces to 15. So I'm going to multiply by 5, and I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 5 is 10, right? 10 15ths. Then 5 times 3 is 15, right? I'm going to come over here and multiply by 3. So I'm going to add 2 lines to section it into 3 equal parts. And now I've multiplied this by 3. I tripled it. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 is 9 15ths, right? So remember, whatever you do to the top, you do to the bottom, because you increase the total pieces to 15 pieces. Now, when you add 10 plus 9, you get 19 15ths. Well, I'm going to pull out the whole. 15 over 15 equals 1 whole, and I'm left with 4 15ths, which is 1 and 4 15ths. Now, if you want to see it in another way, how did I pull out 15 over 15? Well, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I have 15 15ths, I have 1 whole. And I kind of did it in an array. I did it 3 by 5 so that you can connect to that idea of arrays that you learned back in 3rd grade. So 5 times 3 is 15. You have 15 15ths. That gives you 1 whole, and I had 4 1/15ths left over, so I have 1 and 4 15ths. All right. Last problem before we start problem set. All right, we have 3/8. So now we're going to start with, we're going to break this up into 8 equal pieces. So how many lines do I draw? Right, 7. 1, 2, 3, 4, 5, 6, 7. So I have 7. And now I'm going to shade in 3 of these 8s. And now is 3/8, is that greater than a half or less than a half? You're right, it's less than a half. Okay, so you have less than a half. And now we're going to have 2/3. Now, is 2/3 more than a half? Yeah, clearly it's more than a half. So I wonder what's going to happen when you find your common denominator. So that's what you are going to do next. You need to find your common denominator. So I'm going to take my denominators, and I'm going to come over here and I'm going to scoreboard. Unless you can see it right away, what is that common denominator? And then all you have to do is multiply the top and the bottom by that same number. But each one is going to be different because it's going to take a different number to create that common unit, right? All right, so go ahead. I want you to start with your scoreboard. I want you to come over, divide your pieces up, multiply. And you don't necessarily have to use these boxes here. You can always just use the boxes here at the top. And go ahead and solve. Come back and see how you did. All right, so how did you do? Were you able to scoreboard? Are you starting to see the repetition? You're going to start seeing how these common denominators, like, you get used to. When you see 8 and 3, you're going to automatically jump to 24. When you see 4 and 3, you're going to automatically jump to 12. Like, you're going to get used to working with these numbers and seeing those denominators a little bit more easily. So I know that 8 times 3 is 24. I came over here, I multiplied the top and bottom by 3, but also I divided this into 3 and got 24 equal parts. And now I have 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 24s here, and I'm going to add it to, now over here, I had to bring it all the way out to 8. So that's why getting used to and automatically knowing your multiplication, knowing what that common denominator is going to be, makes your life just a little bit easier. Because what if you accidentally make a mistake? 3 times 8 is 24. came over here, multiplied by 8 on the top and the bottom because I'm now dividing this into 24 equal parts. So I multiplied by 8, divided into 8 equal sections, created 24 equal parts, and have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 24ths. So add them together. 9 plus 16 is 25. So I have 25 24ths. So 25 24ths, well, I know 24 over 24 is hiding inside of that fraction. And that 24 over 24 is really just one whole. And so if I pull this apart into its whole and plus add the 1/24th, because 24 over 24 plus 1 over 24 is still 25 over 24. So pull this out and I end up with 1 over 1/24. So writing it out in words, 3/8 plus 2/3 is equal to 1 and 1/24. All right, so let's go ahead and jump to our problem set. Here is our problem set. So for the following problems, draw a picture using the rectangular fraction model. So that's what it's called. The rectangular fraction model are the boxes. And write the answer. When possible, write your answer as a mixed number. So yes, always try to write your number as a mixed number. For these 6 problems, you're going to complete what we just did in our concept development. You're going to work it all out, solve. Then over here for the word problems, always good to practice with your word problems. Solve the following problems. Draw a picture and or write a number sentence that proves the answer. Always simplify your answer. So Penny used 2/5 pound of flour to bake a vanilla cake. She used another 3/4 of a pound of flour to bake a chocolate cake. How much flour did she use altogether? So simply using what you know, right? How much did she use altogether? So altogether means what? That's right, addition. All right, now Carlos wants to practice piano 2 hours each day. He practices piano for 3/4 of an hour before school and 7/10 of an hour when he gets home. How many hours has Carlo practiced piano? Then, so that's the first question. So you have question 1 and now question 2. How much longer does he need to practice before going to bed in order to meet his goal? So he wants to practice 2 hours, right? So that's the whole. That's what you need to go back to, right? So if you're adding it in one direction to find out how much does he want to practice, did he practice all together? Then you have the opposite. You have the inverse operation to figure out how much longer does he still need to practice in order to meet his goal. All right. So go ahead and begin and come back to check your work. I'm sure you will do great. So you're going to come back to part 3 of the lesson to check your work.